So, on my previous video, I basically touched base with the mathematics and genetics, I guess, that is intertwined with the network of computing. So, I'm gonna go on and talk a bit about statistical mixtures. So, statistical mixtures of states are a different type of linear combination. A statistical mixture of states is a statistical ensemble of independent systems. Statistical mixtures represent the degree of knowledge, whilst the uncertainty with quantum mechanics is fundamental. Mathematically, a statistical mixture is not a combination using complex coefficients, but rather a combination using real valued possible probabilities of different states. A number represents the probability of a randomly selected system being in the state. Unlike the linear combination case, each system is in a definite eigenstate. Another feature of quantum states becomes relevant if we consider a physical system that consists of multiple subsystems. For example, an experiment with two particles rather than one. Quantum physics allows for certain states, called entangled states, that show certain statistical correlation between measurements on the two particles which cannot be explained by classical theory. So a way to kind of denote this is through bracket notation. Calculations in quantum mechanics make frequent use of linear operators, scalar products, dual spaces, and Hermitian conjugation. So to a degree, there's similarities between how molecular states or letters are structured and how language is structured. A lot of the literacy used for it is very similar to word construction. In order to make such calculations flow smoothly and to make it unnecessary in some contexts to fully understand the underlying linear algebra, Paul Dirac invented a notation to describe quantum states known as bracket notation. Although the details of this are beyond the scope of this article, some consequences of this are the expression used to denote a state vector, which corresponds to a pure quantum state, takes the form where the brackets can be replaced by any other symbols, letters, numbers, or even words. This can be contrasted with the usual mathematical notations, where vectors are usually lowercase Latin letters, and it is clear from the context that they are indeed vectors. Dirac defined two kinds of vectors, bra and ket, dual to each other. Each ket is uniquely associated with a so-called bra denoted, which corresponds to the same physical quantum state. Technically, the bra is the adjoint of the ket. It is an element of the dual space and related to the ket by Riesz representation theorem. In a finite dimensional space, with a chosen basis, writing as a column vector is a row. To obtain it, just to take the transpose and entry-wise complex conjugation of a consequence. The quantum states of the particle with spin is described by a vector value wave conjunction with values in c to the power of 2s plus 1. Equivalently, it is represented by a complex valued function of four variables. One discrete quantum number variable for the spin is added to the usual three continuous variables for the position in space. Very complex, so I'm going to just leave it there, and I'll say one more thing. So I'm going to leave it there. There's lots of measurements to kind of be considered within this, like from electrons to photons to light to bosons, mass, whether a reaction is happening in a vacuum. So the mechanics of the whole situation is extremely complex, very fascinating. And yeah, I will try and make more sense of it as I go along. But I think at the moment, considering my notes, this is all I'm capable of sharing at the moment. I do hope that this kind of information and education becomes more accessible, once again, for like the development of science. And yeah, like I said before, like I am very frustrated, I think, at the lack of accessibility, the lack of kind of being able to put information in a way that is kind of easily understandable as well. But yeah, anyway, have a lovely day.